The liver is constantly exposed to foreign particles in the nutrient-rich blood from the digestive tract. You might expect the liver to develop hypersensitivity to food antigens and microbial debris, but this usually does not happen. The liver is actively immunotolerant, but it's not defenseless. Indeed, most liver diseases are caused by failure to resolve inflammation once it's started, resulting in acute or chronic hepatitis. Acute hepatitis can be triggered by alcohol, drug-induced liver injury, fatty liver, autoimmune reactions, and of course, viruses. Viruses such as cytomegalovirus, Epstein-Barr virus, and herpes simplex virus can cause hepatitis as part of a systemic infection, but the 5 hepatitis viruses, hepatitis A, B, C, D, and E, replicate preferentially within hepatocytes. Hepatitis A and E viruses are transmitted through the fecal-oral route, whereas hepatitis B and C viruses are usually transmitted through blood and body fluids. Symptoms include fatigue, anorexia, nausea, and vomiting, with alanine transaminase levels greater than 1,000 international units per liter, although presentation can range from subclinical to acute hepatic failure. Acute hepatitis is characterized by a variegated appearance with inflammation around the portal tract, evidence of hepatocyte damage such as ballooning degeneration, and areas of focal necrosis surrounding by infiltrating inflammatory cells. Damage may extend to bile ducts, leading to cholestasis and jaundice. HBV-specific CD8 cells can bind to infected hepatocytes and induce apoptosis, visible as Councilman bodies, which are eventually cleared by macrophages. A key feature of the liver is that damaged hepatocytes are replaced mainly through renewed cell division, and mitotic or binucleate hepatocytes may be observed amidst regions of necrosis. Hepatic stellate cells may be activated and begin remodeling the extracellular matrix, but this process can be reversed as long as the instigating factor is removed. However, if the infection has not been resolved after 6 months, the liver enters a new phase, chronic hepatitis. While acute hepatitis is associated with flu-like symptoms, inflammation in chronic hepatitis is less intense and may be asymptomatic. Although many people are unaware that they have chronic hepatitis, chronic inflammation promotes detrimental and often permanent structural changes in the liver. Fibrosis begins near the portal triad and progresses through the parenchyma, resulting in bridging fibrosis and eventually cirrhosis. Inflammatory lymphocytes remain active in the liver, resulting in interface hepatitis and ongoing cycles of hepatocyte injury and replacement. Severe hepatocyte injury can activate bipotential progenitor cells called oval cells, but proliferation of these cells is thought to contribute to hepatocarcinogenesis. The liver successfully clears most viral infections long before this point, but there are 2 major exceptions. Hepatitis C virus was not discovered until 1989, 6 years after HIV and decades after HBV. However, development of highly sensitive nucleic acid tests around this time greatly increased the safety of blood products. Therefore, many chronic HCV patients were infected before this time. But there's no vaccine, and over 1 million new cases occur each year. HCV enters the liver mainly through the hepatic artery, where it enters the space of Dease through fenestrations in the sinusoidal endothelial cells and interacts with heparin sulfate proteoglycans on the hepatocyte surface. HCV binds to its receptors and is endocytosed into the cell, where it forms a replication complex called the membranous web. The 5' untranslated region of the RNA genome forms an internal ribosomal entry site for translation of the open reading frame into a single polypeptide. Host and virus-encoded proteases cleave the polyprotein into viral proteins. HCV treatment was once long and arduous, with severe side effects from interferon and ribavirin. Now, HCV is often curable in a matter of weeks, using oral medications containing direct-acting antiviral drugs. Treatment of HCV is a success story, but the lack of a vaccine will make it difficult to completely eradicate the virus. Although HBV and HCV can both cause chronic hepatitis, they offer a stark contrast. There's no vaccine against HCV, but an HBV vaccine has been available since 1982. 75% of acute HCV cases become chronic, compared to only 10% of HBV cases. But chronic HBV cases are much more difficult to treat. The main goal of HBV treatment is usually suppression rather than cure. HBV is an enveloped, partially double-stranded DNA virus in the hepatodiviridae and is among the smallest viruses. The lipid envelope contains the hepatitis B surface antigens, which are involved in immune evasion and viral entry. The nucleocapsid is composed of around 180 copies of the core protein and contains the partially double-stranded DNA genome bound to DNA polymerase. The 3.2 kilobase genome contains 4 overlapping open reading frames that encode the viral proteins. HBV enters the liver through the portal vein and interacts with heparin sulfate proteoglycans on hepatocytes. The Prius-1 region of HBs antigen binds to the receptor NTCP, and the virus enters through endocytosis. The virus escapes the endosome, and the nucleocapsid is released into the cytoplasm. The partially double-stranded HBV genome enters the nucleus, where it's converted into a stable cccDNA mini-chromosome. cccDNA also serves as the template for pregenomic RNA, which is reverse transcribed by the HBV polymerase. The genome is enclosed by core proteins to form the nucleocapsid, which interacts with surface proteins embedded in the endoplasmic reticulum to form the envelope. Dane particles are released into the bloodstream, along with a large number of empty subviral particles that serve as immune decoys. Viral replication is suppressed using peginterferon and nucleoside or nucleotide analogs, but as long as cccDNA remains in the nucleus, replication can resume whenever a treatment is stopped. The liver tolerates continuous exposure to foreign antigens, but it's no pushover and responds quickly and decisively to attack. Known for its immunotolerance, though, in the end, the liver is often undone by failure to stand down the immune response, especially when exploited by the expert saboteurs known as the hepatitis viruses.